Hello students, you're welcome to pathology class. Based on the last lecture we had before the lockdown, I just want to run through a few things. I've already told you that the class is going to be taken by two of us, myself and Dr. Ani. So for my part, I'm going to be taking the animal parasitology part. And in the last class we had before the lockdown, I already introduced the course to you. So I'm going to go through a few of the things I introduced during the first lecture. So I want you to concentrate and make sure you go over this video so that if you were not in the class, you'll be able to grab one or two things. So in the introduction class, we talked about biological association. There are associations that exist in life, and every living organism is into one or more association. Now, this biological association can be categorized into two basic types. You have the intraspecific association and the interspecific association. The intraspecific association has to do with association between species. Intraspecific association within a particular group of species. So, for instance, within humans, we are of the same species, so we can interact and relate with each other. But interspecific association has to do with among different species. So relationship between dogs and cats, or dogs and its environment with all other organisms. That's interspecific association. Whatever the type of association, there are different categories or exhibitions of interactions. The interactions could be loose, the interaction could be close, depending on the type of association being exhibited. So all interactions or living together found between species is termed symbiosis. All categories of interactions, whatever it is termed symbiosis. So symbiosis is, simply put, living together between organisms. And in terms of symbiosis, we can give three common examples of symbiosis that is general. We can say these are general. Outside this, there are some other symbiotic relationships, but I'm going to pick on these three symbiotic relationships. You have mutualism, you have commensalism, and you have parasitism. And these were the three we dwelt on in the last class. So let's start from mutualism. And like I said, is an example of symbiotic relationship. So mutualism, from that word, has to do with equal contribution or benefiting from an association together. So it involves a close association between two different organisms, and these two organisms benefit from the association. Both of them benefit from the association. So they both bring to the table in the relationship. And in this regard, we can give an example of the relationship between termites and the microorganism found within termites. Now, these flagellates live within the intestine of termites, and they assist the termites in breaking down the cellulose that it feeds on. And in turn, these flagellates gain from the termite by living inside the intestine. So, like, they have a shelter over their head, living inside the termite. So both of them gain from this association. So you term it as a mutualistic relationship. Now, Next to that, and you have so many other examples of mutualistic relationship. I cited a lot of examples in the class during the lecture. You have another type between the nitrogenous fixing bacteria that live in the root nodules of legumes. Those are other examples that you have, and so many other examples that you find two species living together and contributing and gaining from the relationship. In the class, I termed it as a relationship where there is a plus, if you remember that. Plus, because both of them are gaining. Now, in that kind of relationship, that's mutualism, we can say that the degree of the relationship is very close. So much so that sometimes they are not able to do without each other. Another example, common example you can find under that category is the relationship between algae and fungi, where they form lichen. Okay, so another type of symbiotic relationship is commensalism. And under commensalism, you have an association existing between two organisms in which one benefits immensely from the relationship and the other does not benefit and does not lose. So I termed it as an association of two different organisms in which one partner benefits while the other neither benefits nor loses. So a common example is the organisms that live in the intestine of men, specifically Entamoeba coli is a flagellate. Is an amoeba that lives in the intestinal tract of humans and lives there as a commensal. It doesn't cause any pathological effect. It gains immensely by living there because it feeds on things inside the intestinal tract, bacteria and some other things, but does not cause any harm to the man. So the man does not gain and the man does not lose anything from such association, but the Entamoeba coli gains immensely. There is shelter, it has an abode, and then it is feeding inside that particular environment. So that's commensalism. In the last class, I termed it as a plus zero. So one organism gains, that's the one that has the plus. The other organism does not gain and does not lose, that's the one that has the zero. Now the third relationship is the one we're concerned about, that's parasitism. Now parasitism is an association between two different organisms in which one causes harm to the other. The one that causes harm is called the parasite, while the one that is being harmed is called the host. Now that's where we're going to be concentrating on. Now the host can be harmed to such a degree that the host becomes diseased. Now there are different categories of hosts and there are different categories of parasites, and that was where we stopped, and I said I was going to elaborate on it in our next class before the lockdown. Now there are different categories of parasites, and basically in the class I gave you two categories. I told you there are endoparasites and ectoparasites. Endoparasites are parasites that are found living within their host. Oftentimes, most of them serve as gastrointestinal parasites, or they are found in other organs of the body, the liver, the lungs, and inside the blood of the host. And then you have another category called the ectoparasites. Ectoparasites are parasites that are found living outside the host, and most times they belong to the phylum Arthropoda. Most of them you have examples like lice, mites, ticks, they are found living outside the body of their host. So those are the two major categories I gave to you, and in this category, I gave you an example, the illustration of ascaris living inside the intestinal tract of man, where the ascaris causes harm to the man by depriving the man of the nutrients, because it feeds on the nutrients of the man, and apart from that, causes some other damages to man. Okay, so now we can give it, in the class I gave it a plus minus symbol, plus minus. The plus is belongs to the parasite, because it's the partner that is gaining from that association, gains from that association, while the host has the minus, it is losing from that association. So that's the symbol that you can give to parasitism. So now, like I told you, there are different categories of parasites and different categories of hosts. So, and apart from that, there are a lot of other terminologies we're going to be using in the course of this lecture that you need to be conversant with. So you have to know certain terminologies. But before then, you have to define what parasitology is. Parasitology is a branch of biology that deals with the study of parasites. So we're going to be studying parasites, different types and categories of parasites and their effects on their host. So let's start by looking at types of parasites. There are different types of parasites. You have obligate parasites, facultative parasites, you have accidental parasites, temporary parasites, permanent parasites, zoonotic parasites. Okay, so let's look at them one after the other. What are obligate parasites? Now, from that word obligate, it means that obligatorily that parasite must exist in a host. So it is a parasite that cannot live as a parasite except it is found within the host. In other words, it has to exist as a parasite. Compulsorily, it must live as a parasite. It is totally dependent on the host. It cannot exist as any other thing but as a parasite. So mandatorily, it has to exist as a parasite. So when you find them, oftentimes you find them living within a host. They are obligatorily parasites. A very good example, you have Trachinella spiralis. This is a nematode found living within vertebrates, within the tissue of vertebrates. Obligatorily, that is where they are found. They exist just as parasites. Next to that, you have facultative parasites. Now, facultative parasites, these are parasites that can exist as parasites or at some certain stage in their life as free living organisms. So facultative parasites can exist as living organisms or can be found living as parasites. So when we start looking at some other types of parasites, you will discover that certain categories of parasites fall under this particular example, facultative parasites. Most monogenous parasite, that's it, another type of parasite, when we get there you know what it means, fall under this category because at a particular stage in their life they are found as free living organisms. So at that time they are not parasitic inside any host, and then eventually they get transmitted into a host. So facultative parasites exist both as parasites or as free living organisms. Now, accidental parasites. These are parasites that become parasitic in a host accidentally. For instance, you can find parasites of animal infecting humans. So it's an accidental parasite and ordinarily may not reach its adult stage because it's an unusual environment. It's not a normal environment for it, so it's an accidental parasite in that regard. Then you have temporary parasites. These are parasites that are found for a while on the host. They don't live permanently on the host. They are found temporarily, and most times they come to feed and then leave, or come to take one benefit or the other from the host and they leave. Very common example, you have mosquitoes coming to feast on humans, take the blood and then they depart. They don't live permanently on their host. Then you have permanent parasites. Oftentimes this category are endoparasites. Endoparasites in that they are found within their host, so permanently they are parasites. Then you have zoonotic parasites. These are parasites that are found in animals but can be transmitted to humans. So these are parasites that are found in animals but they can be transmitted to humans. Parasitic both in animals and in humans. These are zoonotic parasites, and you have a lot of examples of zoonotic parasites. You have fascioliasis, you have schistosomiasis, you have trypanosomiasis, and a lot of them that fall under that category. Now let's move to types of hosts. For types of hosts, you have a lot of them there. The first on that list is a definitive host. You can see DH in front of it in case you want to construct a life cycle and you don't want to write definitive host in full. DH, definitive host. What is a definitive host? A definitive host is a host that harbors the adult or the sexually reproductive stage of a parasite. The adult stage of a parasite or the sexually reproductive stage of the parasite. Invariably, for you to determine what type of category a host is, when you take a sample from that host and you want to see, you're checking for the parasites in that host. If the parasite you find in that host is the adult stage of the parasite, or it is the sexually reproductive stage of the parasite, then that host must be the definitive host. Oftentimes they are referred to as the final host. They are also referred to as the primary host. So a good example of that is in schistosomiasis, the human is the definitive host, while the intermediate host is the vector, called snails of different categories. So the definitive host for schistosomiasis is man. For teniasis, the definitive host is man. For malaria parasites, the definitive host is the mosquito. Now, all these hosts I've mentioned, what the stage of parasite you find in them oftentimes is the matured stage, the adult stage, or the sexually reproductive stage of the parasite. Now, let's move to the next host, the intermediate host. In the intermediate host, what you find in the intermediate host is the immature stage, the larva stage, or the asexually reproductive stage of the parasite. So it is also referred to as the secondary host. It harbors the larval stage, the asexually reproductive stage of the parasite. That's what the intermediate host harbors. As an example, the man is the intermediate host in the malaria infection. Man serves as the intermediate host. And in schistosomiasis, the snail serves as the intermediate host. In teniasis, the cattle or the pig, depending on the species of the parasite now, serves as the intermediate host. And like I told you, in the intermediate host, what you find is the immatured stage. That's the sexually immatured stage. That's larval stage of a parasite, or the asexual stage of the parasite. The asexual stage of the parasite is what you find in the intermediate host. Now you have reservoir host as a host that harbors parasites and most times serve as a store where you have the parasites existing in massive or large numbers. Some reservoir hosts may be asymptomatic, they may just be carriers, and as the name goes, reservoir, like a store, and they are important in the epidemiology of most parasitic infection. They serve as a source where probably a vector will pick from and transmit to other potential hosts. So they are very important in the epidemiology of parasites. And examples, you have most wild animals or domestic animals serving as reservoir hosts. Paratenic or transport host, as the name goes, it's a type of host that merely transports parasites from one point to the other. They serve as a means of transporting and act also as a source of infection to potential hosts. The parasite lives in this kind of host, and the host serves as a means of transporting from one environment to another. Okay, so let's go to vector. Vector is also a type of host. So vector is usually an arthropod or other organism that aid in the transmission of parasites, and they actually assist in transporting or moving parasites from one host to the other, or from one environment to the other. So example, most of them fall under the category of arthropods. So you have mosquitoes, you have tsetse flies, you have black flies, you have house flies, cockroaches, you have rodents, you have snails as types of vectors. Okay, as examples of vectors. So you have two types or categories of vectors. You have biological vectors, you have mechanical vectors. Now, biological vectors are a category of vectors that are needed. They are essential in the life cycle of a parasite. They are very important in the life cycle of parasites. For instance, you have mosquitoes as a type of biological vector essential for the life cycle of Plasmodium. In essence, the Plasmodium parasite is not just carried by the mosquito, it develops within the mosquito fully to infective stage before it can be transmitted to man. So development is essential. It takes and mandatorily takes place in this kind of vector. That's why they are called biological vectors. The parasite develops fully into the infective stage in the vector before it is transmitted to the host. That's a biological vector. And you have a lot of other examples. You have tsetse flies, you have black flies as examples of biological vectors. Now, the second type of vector, you have mechanical vector. And from that, they merely transmit from one point to the other. The parasite is not essential in the life cycle. In essence, the parasite does not undergo development within the vector. An example is a cockroach picking up cysts of Entamoeba histolytica with the legs or the wings, and merely dropping it on another a surface or on a food material or whatever. The Entamoeba does not undergo any form of development within this vector. So the vector merely picks and drops, and may not even be essential for the continuity of the life cycle of the parasite. Okay. Now, let's go to the diagnostic stage. Diagnostic stage of a parasite is the stage at which that parasite is identifiable within a particular host sample. Is the stage at which you can be able to say that this stage belongs to a particular parasite. And the infective stage is the stage at which the parasite is able to enter into a host and establish itself in the host. Is the infective stage. So if a parasite is transmitted before it gets to the infective stage, it may not be able to establish itself because it has not gotten to the infective stage where it can establish itself and likely produce a disease condition. So zoonoses are parasitic infections that can be transmitted from animals to humans or from humans to animals. These are zoonoses. And so I think these are basically the terminologies you need to get acquainted with, because by the time we start dealing with the different types of parasites, we'll be using these terminologies often. So just for your reading pleasure, for you to understand more, I decided to put up slides where you can pick one or two other things concerning these different terminologies. You can see hosts in parasitism. The host, it supplies the parasite with nourishment and shelter, and it is oftentimes the injured party, it's the injured partner. Asymptomatic carriers is a person who harbors parasite but has no clinical symptom. Is an important source of infection in epidemiology, and most reservoir hosts fall under this category. They are asymptomatic carriers. They have the infection, but they are asymptomatic. They do not establish any form of clinical signs of this parasite. So you can see the definitive host, which is, I told you, they are also called primary hosts, and they are also called final hosts, and they harbor the adult or the sexually reproductive stage of parasite. Intermediate hosts, also called secondary hosts, or they are also called what's it called? Intermediate host, secondary host. What's this other name? They harbor the larval or the asexual reproductive stage of the parasite, and you have different categories of intermediate hosts. In some parasitic life cycle, you can have just one intermediate host, while in some others you have more than one intermediate host. So they can be classified or categorized as first intermediate host, second intermediate host, depending on the type of life cycle being exhibited by the parasite. So reservoir hosts are the vertebrate hosts which harbor the same species of parasite at the same stage as the human host or as the vertebrate host, as the case may be, and they are an important source of infection in epidemiology. The vector usually is an arthropod, or it could also be some other organisms that carry or transmit parasite to its host. And we have different types of vectors, as we have different types of transmission. So mechanical transmission is passively done by transferring parasites from the vector directly to the host. So passive transmission of infection by arthropods such as flies carrying eggs or cysts of the parasite, while biological transmission is the parasite multiplies and develops within to the infective stage within that vector before it can be transmitted. And I've given examples of these two types. So vectors that exhibit mechanical transmission are called mechanical vectors. Vectors that exhibit biological transmission are called biological vectors. And zoonosis refers to animal diseases which can be transmitted to man. Paratenic host, or also called transporters, is an abnormal host in which some parasitic larvae can survive, but they cannot develop into adult stage. And the reason is that this category of hosts just serve as mere transportation. Sometimes these parasites are found on the external surface of the host. Now, life cycle. Life cycle is the process of a host, of a parasite's growth, development, and reproduction. It may proceed in one or more hosts depending on the species of parasite. As I've been trying to explain, you've been hearing the word life cycle. Life cycle is just a process of development found or exhibited by all living organisms, from egg to nymph to pupae to adults. And for parasites too, they exhibit growth. This is the life cycle process of the parasite. Is the growth, the development, involves the growth, development, and involves the reproductive activities that makes the parasite to mature from very immature stage to the matured stage. And you have different types of life cycle being exhibited. So basically, you have two types of life cycle exhibited by parasites. You have the simple life cycle and you have the complex life cycle. The simple life cycle and you have the complex life cycle. Parasites with simple life cycles have only one host. And the total development of this parasite goes on within this singular host. So undergoes complete development within the host and are described as having monogenous life cycle. Example, you have Ascaris lumbricoides. Ascaris lumbricoides is an example of a nematode parasite. Now, this parasite is found in man, and man is the singular host. So when the cyst enters into man, oftentimes is transmitted by fecally contaminated food, water, or hands. So when it is taken in through the mouth of humans, the parasite develops within the intestine and stays put in the intestine until it matures and produces eggs, and these eggs exit through the fecal sample, the excreta, the stool of the human, outside into the environment. There must be contamination. Contamination must occur. So contamination of food, contamination of water by different means must occur. And this contaminated food, water, or even contaminated surfaces must are the routes by which this parasite gets back into the host. So the life cycle is established in just one host. No intermediate host is involved. Now, in this type of life cycle, you have just one host, and that host is referred to as having monogenous life. Parasite is described as having monogenous life cycle because it has only one host. Now, in the second type of hosts, those hosts are parasites. The parasites are described as having heterogeneous life cycle. Heterogeneous life cycle because they exist in more than one host. So parasites with more complex life cycle involving multiple hosts are described as having indirect or heterogeneous life cycle. And a very good example of that is you have fasciola existing in two hosts. You have the first host, which is the intermediate host. You have snails of limnia species. You have snails, and these snails are the intermediate host of the vectors. And then the second host is the human or the vertebrate, sheep, goat, cow. These are the intermediate hosts. So you have fasciola existing in more than one host. They exist in snails and they can exist in vertebrates. So because it exists in more than one host, they are described as having heterogeneous life cycle or having an indirect life cycle. And when I was talking about facultative parasites the other time and obligatory parasites, I mentioned that there are some parasites that you find them compulsorily as obligatory parasites. They do not exist except they are parasitic in some other a host, and you have some exhibiting facultative parasitism. That means that sometimes they can be found existing in the host. Sometimes they can be found existing in the environment. So if you take the example of this Ascaris lumbricoides. Ascaris lumbricoides exists as a monogenous parasite exhibiting monogenous life cycle. That means it has only one host, and I told you the host is man. But at a particular point in time, it exits man via the stool of the man into the environment. When it gets into the environment, at that point in time, it becomes free living because it is no longer inside a host. It becomes free living. So we can say that Ascaris lumbricoides exists as a facultative parasite because at a point in time it exists as parasite, and another point in time exists as a free living organism. That's when it is in the environment. Okay, so infective stage is the stage when the parasite can invade human body and live in it. When a parasite has not gotten into the infective stage, it may not be able to establish itself. Now, these parasites, how are they able to exist and survive within the compartment of the host? You find out that most of them are found living in the intestine of their host. Some live in the blood. Some live in the oral cavity in the mouth. Some live within the brain. So how are they able to survive within this limited environment? How are they able to exist and survive and still remain parasitic in their host? Now, they are able to survive because they have developed some features that makes them to be able to survive and exist as parasites. So parasites have developed several adaptive features, and this ensures that they survive whatever harsh condition they find within the host. When a parasite invades the body of a host, the host has natural immunity that will try to combat or kill off this parasite. This is just the natural defense mechanism of the body. But some parasites are still able to survive. They are still able to evade the immune system of the human, and they are able to survive. So how are they able to survive? There are different adaptive features that have been developed by parasites, and ensures these features ensures that they survive within their host. So you can see I have listed 4 adaptive features. You have morphological adaptation, life cycle adaptation, immunological adaptation, and biochemical adaptation. So let's start with the morphological adaptation. Now, morphologically, parasites have been structured in such a way that they are able to adapt, they are able to live successfully within their hosts because of their configuration, because of their morphological features, because they have adapted themselves to the environment, the environment they are going to live in. So the first thing is that you find most parasites being dorsoventrally flattened. For instance, a parasite that is going to live inside the intestine has to be flattened such that it will be able to live successfully. It's not too big, not too bogus. It's most times they flatten themselves so much, against the body, the internal cavity of the host, and almost unnoticed. So they are dorsoventrally flattened in shape, and this aids their ability to cling to their host. A good example is the Tinea species. I'm going to be using Tinea species. That's the tapeworm. If you look at the structure of the tapeworm, it is flat, dorsoventrally flattened, compressed, and it is able to cling to the intestinal wall of the host. Another adaptation, morphological adaptation, is that they have lost their locomotory organs or organelles, as the case may be. They do not have, because most times they do not move around as such, and for them to be able to cling so tightly to their host, they have lost all these extra structures. So they just flatten themselves against the host, and if they have to move, they crawl or wiggle around inside their host. Parasites have developed organs of attachment such as hooks and suckers. These are morphological adaptation. Hooks, for instance, if you look at tapeworm, it has hooks and suckers on the scolex. The scolex has hooks and suckers, and these are hold fast mechanisms that they use to attach themselves securely to the host. You remember that peristaltic movement takes place in the intestine, and the churning and everything, but yet they are undetached. These parasites are undetached because they have secured themselves, they have fastened themselves to the host so that they will not be able to be dislodged easily. So they have developed organs of attachment such as hooks and suckers. Also, most parasites have reduced their central nervous systems, and they have reduced sense organs because they are endoparasites and they do not need all these extra structures. Also, some of them morphologically have reduced themselves so much so that they do not have guts, they do not have GIT, that's gastrointestinal tract. For instance, Tinea achene, if you look at the tinea, that's tapeworm, it doesn't have a digestive system at all because it is situated within a compartment of the host where nutrients surrounds it. So the food has been broken down into the simplest form. So it lives inside this environment, and it will just simply absorb the nutrients directly through its skin into its body. So it doesn't need the digestive system. So some of them do not have digestive system, or they have rudimentary, very simple digestive system. So these are the morphological adaptation developed by some parasites. Let's move to life cycle adaptation. We just talked about the life cycle. Now that we have two basic types, the simple, which is the monogenous life cycle, and the complex, which is the heterogeneous life cycle. So, but parasites have adjusted their life cycle in such a way that they are able to comfortably continue and exist as parasites. For instance, most of them have increased reproductive potential. They are able to produce eggs massively, just to make sure that they continue to exist as parasites. Remember that they are trapped within the body of the host, and the chances of them getting out, the eggs getting out, may be reduced, or even when the eggs get out, they may be destroyed, and they may not be able to reach maturity. So, in order for them to be able to exist as parasites, they produce eggs massively. For instance, the Ascaris lumbricoides can produce up to 200,000 eggs per day. The female can produce up to 200,000 eggs per day, and these eggs are able to get out of the host via the stool of the host and contaminate food or water or surfaces, and then they are transmitted through that medium. So that's a very good parasitic adaptation in order to continue existing as parasites. Also, some exhibit hermaphroditism. Hermaphroditism in that they are trapped within the body of the host, and they do not have to wait for the female species, does not have to wait for the host to swallow a male species. They are hermaphrodites, so they have both male and female structures, and their life cycle continues because they are able to produce egg and continue their life cycle. That is a very good adaptive mechanism. Also, some exhibit parthenogenesis. Parthenogenesis in that the young can actually become sexually matured and start to reproduce. Another life cycle adaptation is that they are able to use multiple hosts. So they change from one host to the other, and this also to ensure that they continue to exist as parasites and their existence is not just terminated. They move from one host to another. That's life cycle adaptation. The third one is immunological adaptation. Now, I told you that when a parasite invades the body of a host, the host has natural immunity that makes the body to mount up pressure and kill off the parasite. But some are still able to establish themselves within the host. How are they able to do this? They have different mechanisms that they have adopted. For instance, some parasites absorb the host antigen. So when they coat themselves with the antigen of the host fails to recognize them as foreign. So, and that can be likened to molecular mimicry. They adopt the molecular makeup of the host and mimic the molecular makeup of the host such that the host fails to recognize the parasite as foreign any longer, because it has covered up itself with its own molecular makeup. So they mimic the molecular makeup of the host, and that's how they are able to penetrate into and escape being destroyed by the host. Also, antigenic variation. That's another type of immunological adaptation. They vary their antigenic makeup. They vary it in such a way that at a particular point in time, they weary the antibodies that have been produced against the antigen. A very good example is the trypanosome. It's a parasite that is able to vary its antigenic makeup. The parasite has a particular antigen on its external surface, displayed on the external surface. Once it gets into the host and is about establishing itself, the antigen is recognized by the body, and antibodies are being manufactured against that particular antigen that has entered into the body. Now, when the antibody is produced and released, the antigen recognizes that it has been identified already. So the antigen of that trypanosome is varied. So let's assume the antigenic makeup is ABC, capital letter ABC. It changes immediately after the antibody has been produced against it. So small letter ABC. So let's assume the antibody that is produced against the capital letter ABC is antibody capital letter ABC. The capital letter antibody ABC cannot kill small letter ABC. It cannot, except another antibody with small letter ABC is manufactured to combat that. And before that, the antigen keeps switching and keeps changes severally, to the extent that the immune makeup of the body becomes wearied, because it can change up to 1,000 times. The antigenic makeup of that trypanosome can change for as long as 1,000 times, and it wearies the body's immune system. So antigenic variation, they are able to eventually overpower the body and establish themselves in the host. Now, occupation of sites, of privileged sites in the body. Some parasites are able to occupy some sites in the body, and it is difficult for the immune system of the body to combat them there. For instance, some parasites living in the brain of the host, is very difficult for the immune system to go and tackle those parasites there and kill them there. Some live directly under the skin. Some live intracellular, inside the cell, within the cell. So sometimes the cell itself has to be destroyed for the parasites within it to be killed. So they live inside privileged sites, and that makes them to be able to easily establish themselves within the host. So disruption of the host immune response. These are the immunological adaptation put up by parasites, and makes them to be able to survive within their host and establish. Biochemical adaptation, which is the last one. Most parasites, biochemically, they have adapted themselves to existing as parasites, in that they have reduced their energy metabolism, and they are able to reduce the amount of oxygen they make use of within the host. Most hosts have reduced oxygen within them. Remember, they are trapped within an enclosure, and there is reduced oxygen. So, but they are able to survive. So, some of them exhibit as anaerobic, almost in a near anaerobic situation, or micro aerobic sites. They live there and they are able to exist successfully as parasites. Some, their synthetic reactions are reduced, and some, they exhibit elaborate transport mechanisms. They have structured themselves in such a way that biochemically the energy they use is reduced, and they are still able to make do with the little that is being supplied within the host, and they exist successfully as parasites. So these are the various adaptive mechanisms used by parasites that ensures that they continue to exist as parasites. So in this course, we're going to be we're moving gradually to the parasites now. When we're talking about parasites, we're going to be focusing on 3 categories of parasites. We're focusing on protozoans. Also, we're going to focus on helminths, and we're going to look at the arthropods. These are the 3 categories of parasites we're going to be looking at. The protozoans fall under the category of microparasites. If you were in my first class, we have discussed about microparasites and macroparasites. So the protozoans fall under the category of microparasites. The helminths fall under the category of macroparasites. So we're looking at this parasite extensively from our next class. So we'll start with the protozoans, but just for your viewing pleasure, this is the type of host, a human being, and these are the various parasites that the human being can be predisposed to. So if you look closely, you will see that the eye, you see from the eye, can have parasite called loa in the eye. If you look at the head, you can see head lice. If you look at the arrow pointing to the brain, you can see acanthoamoeba there. See the mouth, one pointing to the mouth, you can see entamoeba gingivalis. Look at the one pointing to the heart, you can see trypanosomiasis. Look at the one pointing to the stomach or the intestine, you can see ascaris, you can see malaria, you can see tapeworm, you can see pinworm, and so on and so forth. So in our next class, we would start looking at these different parasites, starting from the protozoans. So stay tuned. I want to advise you to listen to this over and over again, and if there are any questions, feel free to ask your questions on the platform so that we'll be able to tackle those questions together. See you in the next class.